In this video, I'm going to go through the June 2018 Algebra 1 Regents exam. Now, I got the copy of the answers from the website jmap.org, so thank you to Steve Watson from JMap. I'm going to go through his answer key, but I'm going to go through and explain each question one at a time here. So let's start with the first question on this Regents. Number 1, the solution to 4p plus 2 is less than 2 parentheses p plus 5 close parentheses is. So to do this, all you have to do is solve for p. So you can, on the right side, distribute. You can distribute 2p plus 10, or if you want, you can, since the right side is being multiplied by 2, you can divide both sides by 2 so that there's no more 2 in front of parentheses, and that's what Steve did here. So he divided both sides by 2, and he got 2p plus 1 is less than p plus 5, and then he's going to move some stuff around, and he's going to end up getting p is less than 4. So the answer to this one's choice 4. Question number 2 just wants you to take the value 9. It says k parenthesis 9. That means they want you to plug 9 in to this problem wherever you see an x. So that means you're going to do 2 times 9 squared minus 3 times the square root of 9. And that means you're going to get 2 times 81 minus 3 times 3, which is 153. That's choice 4. Question number 3 wants you to simplify. Now both of these have a number in front of parentheses, so you should use distributive property. And then once you distribute those numbers, you're just going to combine like terms. When you combine like terms, you're going to get choice 2. Number 4, to find the zeros of this function, there's a few ways you could do it. You can see here what Steve did is he set the equation equal to 0, and then he used factoring. He found two numbers that multiplied to negative 24 that added up to negative 2, which was negative 6 and positive 4. And then when you solve each of those factors, set them equal to 0, you're going to get x equals 6 and x equals negative 4. Now, another way you could have found the zeros is to set that equation equal to y and then graph it and look when it hits the x-axis. The zeros of a function is when it hits the x-axis. So question number 4 is choice 3. Number 5, we have a box plot here. The third quartile is just the right side of the inner rectangle. So you can see he labeled all of the sections here. The first part is the minimum, and then the second part is the Q1. The median is the middle of that long middle rectangle. The Q3 is the right side of that middle rectangle, and the max is that outer edge. So Q3 is 90 in question 5. That's choice 2. Number 6, strawberries and raspberries. Strawberries are $1.60 a pound, and raspberries are $1.75 a pound. And altogether, they only can cost up to $10. So if you look, choice 1 shows that it's $1.60 per pound of strawberries, plus $1.75 per pound of raspberries. And when you combine those, when you add, it has to be less than or equal to $10 because we can't go over $10. So that's choice 1. Number 7, this theater's rows increase at a constant rate. Row 3 has 31 seats, and row 6 has 37 seats. That means that each row must be adding 2 seats, right? Because the pattern would go on for rows 3, 4, 5, 6. And for the number of seats, it would have to go 31, 33, 35, 37. So if we're adding 2 rows every seat, or 2 seats every row, if we go backwards a couple rows to row number 1 has 27 seats. Row number 0 would have 25 seats. So that means the equation of this situation here is y equals 2x plus 25. 2 is the number of seats that are added per row, and 25 is how many seats would be in row 0. So once we know that, then we're just going to find row 20 is 2 times 20 plus 25. That would be 65. That's choice number 1. Number 8, which ordered pair is not a solution? So to find this, I would just graph that on my Desmos calculator, and I would trace the graph, and I would see which one is not on the graph. Negative 1, 6 is not on the graph, so that is choice 4. Number 9, students were asked to name their favorite sport from a list of basketball, soccer, or tennis. The results are shown in the table. What percentage of students chose soccer as their favorite sport? So the first thing we need to do is figure out how many students altogether there were in this survey. So since there were only 3 choices, and since they only categorize as boys or girls, we just need to add up all the numbers. When you add up all the numbers, you get 250. That means 250 people were surveyed. And how many of them chose soccer? Well, 99 of them chose soccer out of 250. So 99 divided by 250 would be 0.396. And then to turn that into a percent, you just multiply by 100. So that'd be choice 1, 39.6. Number 10 is a factoring problem. They gave us a trinomial, x squared minus 14x plus 49. So I need 2 numbers that multiply to positive 49 that add up to negative 14. So the only way to multiply to get a positive and add up to get a negative, they would both need to be negative, right? So negative 7 and negative 7. And choice 1 is x minus 7 times x minus 7, but instead of writing it twice, we just wrote it once with a squared. So number 10 is choice 1. Number 11, Isaac is asked to add another point and still keep this as a function. So we can't ever use the inputs of 0, 2, 5, and 7 again, unless we use the same output. So that's why choice 1 is eliminated. We already had 0 paired with 1, so it can't be paired with 2. Choice 2 is already, 5 is paired with 8, so it can't be paired with 3. So that one's out. Choice 3, 7 is already paired with 2, so it can't be paired with 0. Choice 4 is good because we don't have 1 paired with anything as an input. So 1, 3 would be a fine point to add that wouldn't break any rules of functions. So 11 is choice 4. So number 12 is, it says, what is the value of P? So they basically are asking you to complete the square here. So we're going to take that negative 6 and we're going to cut it in half. And we're going to square it and we're going to add it to both sides. So we're going to add 9 to both sides. So we would get x squared minus 6x plus 9 equals 21. And the whole reason we would do that is so we can factor the left side so it's parentheses squared. And that would make it x minus 3 in parentheses squared equals 21. And that's what they wanted. They wanted to know the value after the x in the parentheses, which would be negative 3. So that's choice 3. Number 13 wants to know the smallest minimum value. So choice 1, this is just an equation. You could just graph this. Choice 2, this is just an equation. You can just graph it. Or sorry, that's choice 3. Choice 2 is a graph, so just look right there. That's the minimum. And choice 4 is a table, so the minimum is the number, the vertex in the middle there, 1, negative 6. So after looking at all the minimums here, we got to hopefully find a minimum that's smaller than negative 6. And choice 2's minimum is negative 10. If we see the graphs of these two, they wouldn't go that far down. So the answer to number 13 is choice 2. Number 14, which situation is not linear? Anytime you're adding or subtracting the same amount over and over again, that's that's linear. What we're looking for is nonlinear, which means we're looking for a percentage. We're looking for some growth. We're looking for some decay. We're looking for multiplying by a number over and over again. And that's choice 4 here, right? 15% per year means we keep multiplying by 0.15 or 15%. So number 14 is choice 4. All the other choices would be adding the same number over and over and over again. Number 15, which choice is at least 15 kilometers? So you can see Steve did a lot of work here. Basically, you just have to use the formula page that's in the back of the Regents to do this question. You have to check to see if 10 miles is greater than or less than 15 kilometers. Well, we know that a mile is, we know that 1 kilometer is 0.62 miles. So you're just going to have to go through each choice here. I'm not going to talk through all these choices. He did all the work here for you. You can see that he went through each of these 3 choices and converted and found that 10 miles is the only one that's over 15 kilometers. Number 16 wants to know the range of this function. So to find the range of a function, you just need to graph it and then see how far up and down it goes. So choice 3 shows that this graph never goes below a y of 2, and it goes up and up and up forever, right? So when you graph this, it's going to make a parabola that hits the bottom of its graph is 2, and it hits 2. That's why it's a square bracket. And then it goes up and up forever. That's why it's a infinity sign. So number 16 is choice 3. Number 17 says, what is the constant in this problem? Constant, remember, is just a plain old number, no variable attached, just a plain old number. So 290 is the constant in this problem. And what does it mean if we're adding 290 to 2.50a? Well, 2.50a is going to represent something that might change in this problem, like how many hours he works, or the number of, in this case, the number of cell phone accessories he sells. So the opposite of that, adding a flat 290, would be something that never changes, like in this case, choice 3, the amount he is guaranteed to be paid each week. So number 17 is choice 3. Number 18, which function could represent this graph? So we just need to look at where does this graph hit the x-axis? And then remember, where it hits the x-axis is actually the opposite of its what is part of the graph. Look at choice 2, which is the correct answer. I see x plus 3, x plus 1, x minus 1. That choice, which is the correct choice, means that it hit the graph, it hit the x-axis at -3, -1, and +1. Those numbers are opposites. So it's true, though, this graph hits at -3, -1, and 1. So we need to pick the choice that has all the opposites of that. So 3, 1, and -1, which is choice 2. And he's right. You should just graph this choice and see, make sure that this graph on your Desmos looks the same as the graph on the paper. Number 19, Mrs. Allard wants to know which ones are in standard form. Remember, standard form, the exponents are sorted from highest to lowest. Choice 2 and choice 3 are all in standard form because the exponents are in decreasing order. So choice 3 is correct. Number 20 wants to know which one is not a function that's always increasing over -2 to 2. So Steve drew these dotted lines to show the interval -2 to 2 in all the graphs. Which graph is not always going uphill between those 2 dotted lines that he drew? Choice 3. The dots show the region we're looking at, and you can see the graph goes up and then it starts to go down. Choice 3 is the only one that is not always increasing. Number 21, what is the appropriate domain? Domain is the input. Domain is the allowed x values. So if we're selling ice cream and C represents the number of ice creams sold, we're not allowed to sell negative ice creams or decimal ice creams or fraction ice creams. So choice 2 shows us we're only allowed to sell integer numbers of ice creams bigger than 0 or equal to 0. You could sell 0 ice creams. You could sell 1, you could sell 2, you could sell 3, but you can't sell negative and you can't sell decimals. That's why he picked choice 2. Number 22 wants to know how many solutions does this have? He did a whole bunch of work here. I would just graph it. Just graph this equation, change the 0 to a y, and it hits the graph 0 times. It hits the x-axis, sorry, 0 times. This graph will never hit the x-axis, so that means it has 0 solutions. Number 23 wants you to rewrite this equation in terms of L. So to get L alone, we would have to move the 2w to the other side and then divide by 2 to get the L alone. And all 3 choices show that correctly done. They moved the 2w to the other side and then they divided everything by 2. And you could test this by putting, making up an L and a w. So like if our L was 5 and our w was 10, you could plug those numbers in and find out what is the perimeter of a rectangle with a length of 5 and a width of 10. So 2 times 5 is 10 and 2 times 10 is 20. So 20 plus 10 is 30. The perimeter is 30. You could put those numbers that I just said into all of these choices and they would all get the same answer. They would all make true statements. So that means that that all 3 choices are correct. That's why he picked choice 4. Number 24 wants you to use this, recursive formula here. The function says to find a number in the pattern, it's the last number times the number in the pattern we are currently working on. So the first number is 1. That's why it says A1 is 1. So the second number in this pattern is the last number times which number are we working on? We're working on the second number. So 2 times 1 is 2. The third number is going to be 3 times the last number. The fourth number is going to be 4 times the last number. The fifth number is going to be 5 times the last number. So you can see the table here. He shows a little diagonal arrow to show that it's the n times the last number. So you can see the fifth number would be 120, which is choice 3. All right, now into the part 2. Question 25 wants us to graph this over the domain. So all you have to do to graph this is to just plug in all the values. The domain says -2 to 7. That means you just need to plug in all the numbers between -2 and 7 into that equation and get the output. So some of the numbers, when you plug them in, they're going to get decimals. So you can see that he only plugged in 4 numbers into the graph, and that's all you need as long as you connect the dots with line between. And you can see he didn't put arrows on either end. That's because the domain, -2 to 7, it's stopping on both sides. They don't want us to make the whole graph forever. They only want to make the graph between -2 and 7. Remember, you can use your calculator to get the values. You can go into Desmos and you can type in this equation and then look at the table and take the values from the table and put it onto the graph. He didn't do this. I would recommend, just in case, that you label the graph with the equation, just in case. All right, number 26. Caleb claims this is non-linear. If it's linear, then that means that the y's are going to go up at a constant rate. The x's are going up at a constant rate. The y's also need to go up at a constant rate. If this was linear, then the x's keep going up by 1. The y's would need to keep going up by 2, or they need to keep going up by 7. They keep going up by a different number. That means this is non-linear. Number 27, solve this equation. This is a quadratic equation. So use the quadratic formula. This does not say that you have to use the quadratic formula. It does not say algebraically. It doesn't even say show your work. So you could graph this on your calculator and you could find where it hits the x-axis, and it would hit the x-axis at 1.8 and -2.8. And actually, you can see he says check using the graphing calculator. If you are going to use your calculator to graph this, I would just sketch the graph on the paper to tell them where you got your answer. Even though it doesn't say show your work, you should explain where your work came from so that they can give you credit. Number 28 says take the graph that's already here and move it. They added 2 inside parentheses. When you add 2 inside parentheses, that means to move it to the left 2 units. So all you had to do for this question was draw the exact same graph 2 units to the left. And that's what he says. Number 29, when the apples dropped from a tower 256, the function right there tells you the number of seconds it takes to hit the ground. So when it hits the ground, then the answer to the problem is 0. That's because this output here represents the height of the apple. So here's a nice equation for you to graph or solve. To solve it, you would just put the 256 over here and then divide both sides by 16. And then to get rid of the squared, you would square root. You could also graph it and then see where it hits the x-axis. And it would hit the x-axis at t is 4. Now to graph it, you would probably need to change the t to be an x and the h of t to be a y, but you'll get the same answer. And again, if you're going to do it graphically, this says algebraically, so graphing would just be good to check your work. I didn't see the word algebraically here. So you can't graph it to get your final answer here, but you can graph it to check your work here. That 4 seconds is the answer. Number 30 wants you to solve this. So to solve this, all you have to do is, looks like, that's interesting. That is not how I would have solved this. I would have distributed the negative 2/3 to everything in the parentheses. And then I would have combined like terms because we have a 6 out here that would be combined with this negative 10/3. And then I would move everything around to get the x alone and get 4/7. Even checked it, which you don't have to do. Number 31, is the product of these two numbers rational or irrational? So if you multiply two numbers that are rational, you're going to get a rational outcome. Square root of 16 is rational, right? The answer to that is 4. And 4/7 is rational because any number that's a fraction is rational. So when you multiply two rational numbers, you're going to get a rational answer. And you could actually multiply those if you wanted. 4 times 4/7 would be 16/7, and 16/7 can be represented as a decimal that ends or repeats. Number 32 wants you to graph this piecewise function. This is what we talked about the other day at our review. Basically, you're going to graph this part only for x's smaller than 2. And then you're going to graph this part for x's that are only bigger than or equal to 2. So you can see they made a table for the top part, and they only used up to the 2. And then they made a table for the second part, and they only used numbers bigger than 2. Now the first part says not to use 2, and they still use 2. And that's because you need to put an open circle on that number to show that it's not actually allowed to be used, but it's the boundary of numbers that are allowed to be used. So you can see they graphed each one separate here. This is for the x's that were smaller than 2, and this is for the x's that were bigger than or equal to 2. Now into the part 3. Question 33 says, there's a function. What does it mean that we're multiplying by 20 and 1.014? Well, this is an exponential growth formula, right? The formula for exponential growth says multiply the starting value by the rate represented as a decimal, and then you add 1 to it. So that would mean that 20 is the starting value, which in this case would be the number of rabbits we started with, and the 1.014 is the rate at which the rabbits were growing, but the 1 is added on. So that means that it's 0.014 is the rate, but as a percent, that would be 1.4%. And you get that by moving the decimal twice to the right. The average rate of change from day 50 to 100, all that means is you need to just find how many rabbits there would be on day 50 and find how many rabbits there would be on day 100. And then rate of change, to find rate of change, you just use the slope formula, which is how much of the y is changing. They're changing by roughly 40, divided by how much of the x is changing, which is in this case, how much of the day is changing. So it's going to be roughly 40 divided by 50, which is about 0.8 rabbits per day. Number 34 wants us to compare these two parking garages. So if x is greater than equal to 2, this is the equation that they would use. And for x is greater than or equal to 2, this is the equation that this garage would use. So the first parking garage charges $7 to park for the first 2 hours, and then each additional hour costs $3. So this he started with the $7 for the first 2 hours, and then it's $3 for every hour beyond hour 2. So you don't want to just make this X because they already paid for the first 2 hours. So that's why they're taking 2 away from the number of hours, because we already paid for the first 2 hours right here in the 7. Same with this one, it's X minus 2, because we don't want to charge them $3.25 for every hour, just every hour after the first 2. And then this question wants us to find out when would these two parking garages be the same. So all that means is you would set these two equal to each other, which is what he did here. So he set them equal to each other, he distributed, and then combined like terms and got all the x's on one side, and got 4. After 4 hours, these two would be the same. You can see he also actually made a table for each to see that after 4 hours, they would both be $13. Number 35 wants us to graph the system of inequalities. Remember, when you graph an inequality, it's a lot easier if the y is all by itself. So he did that over here. You can see he moved the 3x over to the other side with the 14, and he divided everything by 2. And once the y is alone, you can use our slope and y-intercept, or you can just put this in Desmos and then copy the values from the table. This one needed to be shaded to the left, and it needed to be a solid line. This one needed to be shaded to the left, and it needed to be a dashed line. So actually his line is not properly dashed here, unless just this is a poor copy. So 4x minus 2, this line here should be dashed. I think I can kind of see his dashes here. And then you can see he labeled the area that was shaded twice with an S. Sometimes the question will ask you to do that. Make sure it's obvious that it was shaded twice. And then it says, is 1, 2 in the solution set? Well, 1, 2 is right here. That's on the line. And this is a dashed line, so it should not be included. It is not a part of the solution set. Number 36. To do linear regression, remember, make all these values into a table on Desmos, and then you're going to do y1 squiggle m x1 plus b. That gets you all of these values here, so you can write your equation, your linear equation. And it says round all values to the nearest hundredth, so that means 2 digits after the decimal. So that's why the answer is y equals 0.96x plus 23.95. The correlation coefficient from this question on Desmos is 0.92. What does that mean? That means that this is a very strong positive correlation between these scores, between the scores on math and ELA. Remember, 1 is the best it could be and 0 is the worst it can be. So 0.92 means it's basically a very strong positive correlation. And then the last question here. Dylan has a bank that sorts the coins. So write a system of equations. That means two equations. So the number of dimes times 10 plus the number of quarters times 25 equals 1755. That's the first equation. And then the second equation is just dealing with the fact that there's 90 coins. So the number of dimes plus the number of quarters is equal to 90. And then you would just solve this equation algebraically. You could use elimination method, which is what he did here. He multiplied the bottom equation by 10 so that these 10 d's would cancel. And then he ends up getting quarters is 57. Notice how they only ask for the number of quarters. You could find the number of dimes, but you don't need to know. By the way, the number of dimes in this question would be 33 because it said that there's 90 coins in all. And then the last part of this question, if Dylan's mom replaces each dime with a quarter, then Dylan will have 90 quarters. 90 quarters would be $22.50. If you add the 8% sales tax onto this $20.98 game, it would be $22.65, and that would not be enough for him to buy it. All right, well, that's it. That's everything from this Regents exam, which was given in June of 2018. I wish you luck on your Regents this year, and if you have any questions, please feel free to reach out. Thanks. Have a good day.